Hello everyone, welcome to this video. In this video, we would like to discuss how to find out the effective resistance of multiple resistors that are connected in series and how the voltage gets distributed in the series. This is what our topic is. In this case, we are taking only two resistors into consideration just for the sake of simplicity. Let's assume these are the two resistors. Let me call this resistance as R1. This resistance is R2. If the resistors are connected end to end like this is called a series connection. For any current to flow, we should always connect a battery. So let me connect a DC battery. This is the positive plate of the battery, this is the negative plate of the battery, and a battery is connected. This battery is having some ability to pass the current, that's a voltage V. So from the positive plate, conventional current starts I. This current I will go like this, first through the resistance R1 and then entire current will go to the resistance R2 and then comes back. So the first understanding that we have is the current in this circuit is same across all the elements. Means what? Whatever the current that starts from the battery positive plate will go to resistance R1 and then to R2 and then comes back to the negative plate of the battery, and that will keep happening. That means I series is equal to I1 is equal to I2. Current is same, current is not divided. Then what happens to the voltage? We know there is a law called Ohm's law. We have learned about this earlier, which says that V equal to IR, voltage is equal to current into resistance. As current is same, resistance is different, voltage will be shared across different elements. So what we can say, the total voltage V, that whatever is available in the circuit, is divided across two elements, V1 and V2. How that is distributed we will discuss in this video itself after a few minutes. So I can say the total voltage is, some voltage is dropped at V1, some more voltage is dropped at V2. This is nothing but energy. So the total voltage is V1 plus V2. Voltage is shared across them. Now using the Ohm's law, I can write V equal to IR. So this is V total. So I series and R series. V1, so I1 and R1. V2, I2 and R2. But the thing is, I is same, I series, I1, I2 all are same. Therefore, this I series, this I1 and I2 will be cancelled. So what's the remaining is, resistance in series is equal to R1 plus R2. If there are three resistances, I could have been getting a formula R1 plus R2 plus R3. That's how we can find a effective resistance in circuit when the two resistors are connected in series. Now the next point we would like to talk is how the voltage is distributed across them. We know, as I said, voltage is equal to I into R as per the Ohm's law. How much is the I1, V1 is, how much is the V2 is, I want to calculate. We know in series current is same, so I series equal to I1 into I2. I will use the same Ohm's law, V equal to IR. That implies I is equal to V by R. So I series is nothing but equal to total V by R series. I1 is from this point V1 by R1. I2 is, all are equal actually, V2 by R2. But we already found that R series is equal to R1 plus R2. So V series by R1 plus R2 equal to V1 by R1, which is also equal to V2 by R2. Using these two things into consideration, I can write a formula V1 is V series. Let's just get this to this side, into R1 by R1 plus R2. So the voltage across the first one is, V series is nothing but V itself, it's the total voltage, into R1 by R1 plus R2. That's across, that's when we use the first two. But if you use these two, let's write one more equation using those two. What we will get there? Let's write Yeah, V series, this one I am writing. R1 plus R2 equal to, this one now I am referring, V2 by R2. That implies V2 equal to, take the R to the other side, it will go to the numerator, Vs into R2 by R1 plus R2. So the V2 is, Vs is nothing but the voltage in series, that's nothing but the total voltage V, VR2 by R1 plus R2. This is how the voltage is distributed. Simply to put, V equal to IR, I is constant in series, so voltage is directly proportional to resistance. More resistance is there, more voltage drop will drop happens across it, and vice versa. Thank you for watching.